So here we're given pictures. We have to find the equations. So let's see what we know. This first one, number 38, we see the transverse axis is the y-axis. So the y term is going to come first. So here's the shape of the equation for the hyperbola. This one, number 40, is going to be x squared over something minus y squared over something equals 1 because the transverse axis is the x-axis, so x comes first. Okay, so now we can see the vertices that the point 0, 1 is a vertex and it's in the y direction. So 1 must be the number under the y. Okay, then I can see that the line is y equals x. So that means I went up 1 and over 1 to get to this point on the line. So that means in the x direction, I also went a distance of 1. And I can find the focus points if I needed them, because c squared would be 1 plus 1, or 2. So c would be plus or minus square root of 2, and you can see how they would be inside the hyperbola shape. Okay, but all that we got asked was to write the equation, so we don't put these divide by 1s. We're going to put y squared minus x squared equals 1. And let's do number 40 together. Okay, so then objective 3 is allow the center to move, and the hyperbola moves with its center. So we're going to have some tricky problems. So let's look at number 44. Where the center is at 1, 4. So this is the center, and see how I label them, so when I go look at them later, I know what I'm looking at. So negative 2, 4, that's going to be a focus. And a vertex at 0, 4, so there's a vertex. So because of the symmetry of the hyperbola, we can tell we're going to have another vertex right here at 2, 4. And we're going to have another focus point, another 2 away. So I know my hyperbola's transverse axis is horizontal, which is parallel to the x-axis. So I know the x term comes first. And I always write what I do know as I go along. So I know where the center is, so I got minus 1, minus 4. Now I just have to figure out what the denominators are. Well, if I know the distance from the center to the vertex is 1, then that means in the x direction I went 1. Okay, now if I know where the focus is, I know what little c is. So that's 1, 2, 3. So little c equals 3. So c squared equals 9. And that has to equal 1 plus the other denominator. So the other denominator has to be 8. So here's my equation for the hyperbola. X minus 1 squared minus y minus 4 squared over 8 equals 1. And so I need to put the y direction points, square root of 8's between 2 and 3. So I make my box, draw the diagonals, they should go through the center. Well, now you really want to remember your point slope form of the equation of a line, because that's going to be the easiest way to do these. Because I can tell what the slope is. I know this distance is square root of 8, also known as 2 root 2, but give me a second. So I'm going up 8 and over from the center to the vertex. I drew this picture wrong, so let me fix it. The graph doesn't go through the focus points. The graph goes through the vertex points. So I need to go vertex up to those points. There we go. So now I've got my asymptotes with the right slope. So it's square root of 8 up over 1. So m is the square root of 8, which I need to call 2 root 2. So there's the slope. And my center is the point I know that's on the line. So it's going to be y minus 4, the y coordinate of the center, equals m, which is 2 root 2, times x minus 1. And this is the point slope form of the equation of a line. And now we know that also the negative 2 root 2 is the slope of the other asymptote. So these are the asymptotes. Okay, so we know where everything is. So let's look at number 48 together in class. And then here's some problems that are a little trickier. So this one, the first step you have to do is divide both sides by 9. You have to have that equals 1 as the form before you go deciding what the A and B should be. So I'm going to find my center is going to be negative 4, 3. So there's my center. Then in the x direction, I'm going to go 3 in the positive direction, 3 in the negative direction. And those are going to be vertices because the x term comes first. So I know the transverse axis is going horizontally. And then under the y term, I see a 1. Well, you can't see the 1, it's invisible, but there's a 1 there. So that's how I make the rectangular box. Then I draw the diagonals of the box. And I can see that the slope of the box is up 1 over 3. So the slope is 1/3. So I have y minus, let me try that again, y minus 3 equals 1/3 times x plus 4. And then the other asymptote is going to be y minus 3 equals negative 1/3 x plus 4. And then once I have the asymptotes drawn, I can draw the hyperbola. Make sure it looks like it's approaching the asymptotes. So here's my asymptotes. Vertices, I can see off my graph, is up 3 and I'm at negative 1, 3, and then negative 1, 2, 3, 4, 5, 6, 7, negative 7, 3. That looks good. So now we need the focus points. Well, c squared is the sum of the denominators, or 10. So c equals plus or minus root 10, which is a little more than 3. So the focus point is here, and it's the square root of 10 to the right and left of the center. So it's going to be negative 4 plus root 10, comma 3, and negative 4 minus root 10, comma 3, and those are the focus points. So the transverse axis, we can see from the picture, we need to write the equation of a line. So it's y equals 3. Look at all the points. They all have y equals 3. So I'm sure I got that. And then from the picture, I get the vertices, I get the foci, and the asymptotes. So we'll look at number 58 together. Again, it's a complete the square twice problem. And then if you have sent me ask your instructor problems, I will answer those too.